Yes, hello everyone, welcome back to our channel students. So in this video we are going to talk about ozone. The formula is O2. I know that most of you have studied regarding ozone layer, depletion of ozone layer, the uses of this ozone layer in our previous classes also. So you know that ozone, the formula is O3, clear? So what is the use of this ozone? It is that it protects the living organisms in the earth from the dangerous ultraviolet radiations which are released from the sun. So now this is the mother earth we have, and this is the layer of ozone. Yeah. This is earth, this is earth, this is ozone layer, and we have the sun over here. Clear? So the sun will releases its own sunlight. This sunlight consists of ultraviolet radiations, also UV radiations also. These ultraviolet radiations are dangerous for our living organisms. Clear? So for humans it causes some skin cancer, some skin allergies. Mostly it is effective. Clear? So what is the role of this ozone? So these ultraviolet radiations which are released from the sun before entering to the earth, it crosses this ozone layer. So this ozone layer blocks the ultraviolet radiations, or it reflects the ultraviolet radiations, and thus it stops the ultraviolet radiations from reaching the sun, and thus it protects the living organisms from the dangerous or hazardous effects of the ultraviolet radiations. Clear? So now let us see how this ozone layer is formed. It is formed by ozone is formed by the atmospheric oxygen in the presence of sunlight. In the presence of sunlight. Clear? So this is the sun. Clear? So this is how the ozone is formed. Ozone layer is formed. It is formed by the presence of the atmospheric oxygen in the presence of the sunlight. Clear? So how can we prepare ozone? That's our next question. So now, how can we prepare ozone? We can prepare ozone by atmospheric oxygen itself. Clear? So this should be pure and dry oxygen. Pure and dry oxygen. Clear? When this is passed through silent electric discharge, silent electric discharge, it produces O3, that is ozone. Clear? So this reaction delta H is plus 146 kilojoules per mole. 142 it is actually plus 142 kilojoules per mole. So it means that delta H is positive. Delta H is positive means it is an endothermic reaction. Endothermic reaction. Okay. So this is not balanced O2. So we have 3 and 2. Clear? So now it is balanced. See, this is simple methods of preparation of ozone. Preparation of ozone. We have atmospheric oxygen, pure and dry atmospheric oxygen. When this is passed through silent electric discharge, we get the ozone, and the delta H value for this reaction is plus 142 kilojoules per mole. That means it is an endothermic reaction. What do you mean by endothermic reaction? So we need to pass energy in order to make these reactions happen. Clear? So in order to get this reaction, we are using this silent electric discharge in order to prevent the decomposition. Clear? So this is the simplest way of preparation of ozone. Now coming to its properties. Ozone is a very good oxidizing agent. properties. It is a very good oxidizing agent. Can prove it by when this is treated by lead sulfide, this ozone, we get lead sulfate PbSO4 plus dioxide. Clear? So when ozone is treated with PbS, that is lead sulfide, it produces lead sulfate and with the liberation of dioxide as the byproduct. So this reaction shows that this is not balanced. Oxygen 3 and oxygen 4, so plus 12 and 8. Yeah, now it is a balanced reaction. Yeah, so this is the balanced reaction. Now it is 4. It is 4. So this reaction shows that ozone is a good oxidizing agent. And next, ozone liberates dioxygen, and when this monoatomic oxygen, we call it as nascent oxygen. Nascent oxygen. So this reaction shows that ozone is a very reactive. Here, ozone is very reactive. Yeah. So it produces dioxygen and monatomic oxygen, we call it as nascent oxygen. Clear? So now the next concept is the depletion of ozone layer. So what are the reasons for depletion of ozone layer? You know that we have studied regarding this in the previous classes also. Depletion of ozone layer is a problem because we need to protect ozone layer. Why it is so? Because ozone layer is protecting us from the dangerous ultraviolet radiations which are releasing from the sun. So depletion of ozone layer is our main problem nowadays. The reasons for the depletion of ozone layer is the usage of chlorofluorocarbons. We call it as freons as refrigerants. We use fluorocarbons, we call it as freons as the refrigerants. Okay, that's the first reason. And the second one reason is the nitric oxide. Nitric oxide will be released from the supersonic jet planes. Clear? Supersonic jet planes releases nitric oxide from supersonic jet planes. What does this do? What does this nitric acid which is released from supersonic jet planes do? Clear? So when this nitric oxide comes in contact with the ozone, it converts this ozone to NO2 and dioxygen. Yeah? So nitric oxide is converted to nitrogen dioxide and ozone is converted into O2. Clear? When it is in the form of O2, it loses its characteristic. Clear? Actually, ozone is a dark blue gas. It is actually blue gas. The layer is consist of dark blue, pale blue gases. Clear? So this ozone, when it is treated with nitric oxide, it is converted into dioxygen and loses its property. These are the two reasons for the depletion of ozone layer. So in this concept, the preparation of ozone layer and the reasons for the depletion of ozone layer is very, very important. Yes, the next important element in group 16 is sulfur. sulfur, it is denoted by S. Yeah, and we have more than 20 allotropes for sulfur, but we will be focusing on only 2 allotropes, that is rhombic sulfur, and the next one is monoclinic sulfur. Monoclinic sulfur. Clear? Rhombic sulfur is known as alpha sulfur, and monoclinic sulfur is known as beta sulfur. When we look at the properties of these 2 allotropic forms of sulfur, rhombic sulfur is stable at room temperature, whereas this is not much stable. Yeah. So coming to the melting point of rhombic sulfur is 386 Kelvin, whereas melting point of monoclinic sulfur is 393 Kelvin. Yeah, it is 393 Kelvin and it is 386 Kelvin. Yeah, so it has the same. It has S8 molecules. And even this also it has S8 molecules. So first of all, how can we prepare monoclinic sulfur? The one interesting thing regarding this is we can prepare monoclinic sulfur by rhombic sulfur itself. See, when we cool this rhombic sulfur about 369 Kelvin, that is that particular temperature, we call it as transition temperature, we call it as monoclinic sulfur, right? This 369 Kelvin, we call it as the transition temperature. Clear? And the next important thing is this is not soluble in water. Both this rhombic sulfur and monoclinic sulfur are not soluble in water. These are soluble in carbon disulfide. Clear? And even this also monoclinic sulfur also, it is soluble in carbon disulfide. This is regarding the properties of this monoclinic and rhombic sulfur. When we look at the structure of this two, we have a crown-shaped structure for rhombic sulfur. It represents the S8 molecule. For example, this is the structure of rhombic sulfur. We have S8 structure, S8 ring for rhombic sulfur. This is rhombic sulfur. And in case of monoclinic sulfur, we have chair form. It is. Yeah, so this is S6. Coming to the bond length of these two, this is, we have 205 picometers and this is 204 picometers. Yeah, sulfur, and bond angle is 107 degree for rhombic sulfur, whereas 102.2 degree for this monoclinic sulfur. So this is regarding the properties of two different sulfur, one is sodomic sulfur and monoclinic sulfur. First of all, this is stable at room temperature. You get monoclinic sulfur when you increase the temperature. That means when you cool this aromatic sulfur above 369 Kelvin, you will get monoclinic sulfur. Okay? And melting point of aromatic sulfur is 386 Kelvin, whereas melting point of monoclinic sulfur is 393 Kelvin, and it has a same molecule system, both the same for both this. And it is soluble in CS2 carbon disulfide, but not in water. In the same case, monoclinic sulfur also soluble in carbon disulfide itself, and it is not soluble in water. So the next compound of sulfur is sulfur dioxide. The formula is SO2. This sulfur dioxide can be prepared by sodium sulfide in 2SO3 when it is treated with dilute sulfuric acid. You will get sodium sulfate plus SO2. Yeah. So this is the simple preparation of SO2. Simple preparation. Yeah. When you treat NaOSO3, that is sodium sulfide with dilute sulfuric acid, you will get SO2 sulfur dioxide. Okay. And coming to its properties, this sulfur dioxide, when it is treated with water, it forms acid called sulfurous acid, which to SO3 is the sulfurous acid. When this SO2, when it is treated with sodium hydroxide, it's a base. When this sulfur dioxide, when it is treated with sodium hydroxide, it forms Na2SO3. That means sodium sulfide and with the liberation of water molecule. Clear? So when this sodium sulfide again on treating with the sulfur dioxide, it forms sodium bisulfate. The liberation of water molecule. Clear? So the water molecule over here. So the liberation of water molecule. So it is that when sulfur dioxide is treated with water, it forms an acid. When this same sulfur dioxide is treated with a base, that is sodium hydroxide, it forms sodium sulfate. When again on further reacting with SO2 with the sulfur dioxide, the same thing, it forms sodium bisulfate. Yeah. And we look at the balanced equations. So second one is balanced. Sodium, it is 2 over here. So write 2 and write 2 over here and over here. It is balanced now. Clear? So this is the reaction with acid and a base. When we look at the reaction of SO2 with chlorine, it forms SO2Cl2, that is sulfuryl chloride. Clear? So these are the chemical properties of sulfur dioxide, and we have a test. To denote in order to know the presence of sulfur dioxide. It is that when we pass this sulfur dioxide with KMnO4, that is potassium permanganate. It will decolorize. Yeah, so it will lose its color when you have the potassium permanganate, when you pass this sulfur dioxide gas. Clear? So this potassium permanganate will lose its color. It means that it will get decolorized. That decolorization is the indication of the presence of sulfur dioxide. Clear, students? So this is regarding the preparation, simple preparation of sulfur dioxide and its chemical properties, and a test to detect the presence of sulfur dioxide. So in this video we are ending up here. Let us continue the next concept in the upcoming video. Thank you.